Hello, my name is Dr. McNabb, and today I'm going to be teaching you the basics of stoichiometry. With these 4 charts, you'll be able to do mass-to-mass conversions, mole-to-mass conversions, mass-to-mole conversions, and mole-to-mole conversions. So first we're going to perform a mole-to-mole conversion. Potassium reacts with magnesium chloride in a single replacement reaction. If 1.7 moles of potassium are consumed, how many moles of magnesium are produced? Once you've made sure that your chemical equation is balanced, you can begin. So first I'm going to refer to our mole-to-mole conversion chart, which is the last and shortest of the 4. The first thing you need to remember is that mole A is what you are given and mole B is what you're trying to find. So on the top left, it wants me to write the amount of moles given. Once I look back at the problem, I can see that I'm given 1.7 moles. So this is how it should look when you start, 1.7 moles of potassium. Next I'm going to write how many moles of what I'm trying to find are in the balanced equation. The problem is asking me how many moles of magnesium are produced, and when I look at the balanced equation, I can see that there are 2 moles of magnesium. Then under that, you're going to write how many moles of what you're given are in the balanced equation. I'm given moles of potassium, and in the balanced equation, there's no number in front of K for potassium, which means I'm just going to write 1 mole K. So once you have your chart finished, you're going to multiply across the top and divide by the bottom. When I multiply across, I get 3.4 over 1, which means I end up with 3.4 moles of potassium produced in this equation. Next, we're going to do a mass to mole conversion. In this equation, silver and iron switch places in a double replacement reaction. If 36 grams of silver are produced, how many moles of iron were used? So now I'm going to look at our mass to mole conversion chart. And on the top left, we're going to put mass given. We are given 36 grams of silver. And this is what your chart should look like so far. Next, we just simply put 1 mole of A. A is what we are given, which is silver, so I just wrote 1 mole Ag. Under 1 mole A, we're going to write the mass of A found in the periodic table. When you look on your periodic table, find silver, and under Ag, you'll find a number, which is 107.87, and that is the mass of silver. So that's what your chart should look like so far. So on the top right of our chart, we're going to put mole B in the balanced equation. Mole B is what we're trying to find, and we're trying to find moles of iron. So now we look at our balanced equation. Fe is iron, and in front of Fe we have a 4 and a 2, but you always take the biggest number. So I wrote 4 moles of iron. And finally, on the bottom right, we're going to put how many moles of A are in the balanced equation. Mole A is what we are given, which is silver, and when you look at the balanced equation, there are 4 moles of silver and 8 moles of silver. So like I said before, you always use the bigger number, so we're going to write 8 moles Ag. So now I'm going to multiply across the top, and I end up getting 144. Then we multiply across the bottom and get 862.96. So when you divide 862.96 into 144, you end up getting 0.167, which gives, I'm going to round that up, and it gives me an answer of 0.17 moles of iron. So next we're going to do a mole to mass conversion. In this problem, strontium and iodide combine in a synthesis reaction. If 0.83 moles of strontium are used in this equation, how many grams of iodide are there? So first we're going to look at our mole to mass conversion chart, and on the top left it says to write the given amount of moles. This problem provides us with 0.83 moles of strontium. So that's what I wrote at the beginning of my chart. Next it wants us to write mole B from the balanced equation. Mole B is what you're trying to find, which is iodide, and there are 2 moles of iodide in this equation. So next to 0.83 moles strontium, I wrote 2 moles of iodide. Next, our chart says to put how many moles of A are in the balanced equation. Mole A is what we are given, which is strontium, and there are no numbers in front of Sr in the equation, which means you just write 1 mole Sr. Next, we're going to put the mass of B found in the periodic table. B is what we're trying to find, and this equation is asking for iodide. So when you find iodine on the periodic table, look under the capital I, and you'll find that iodine is 126.9 grams. So once you write the mass of iodine, you simply put 1 mole B under that. Now that my chart is finished, I can multiply across the top and across the bottom and divide them. When you multiply across the equation, you end up getting 210.654 over 1, which means the answer to this equation is 210.7 grams of iodide. Our last conversion will be a mass-to-mass conversion, which is the longest of the four. This is a single replacement reaction, and once you've made sure it's balanced, you can begin. So if you have 21 grams of barium, how many grams of silver were used? And first we're going to look at our mass-to-mass chart. So on the top left, it says to put the mass given, which is A. We are given 21 grams of barium. So this is what your chart should look like. Next, you just put 1 mole A. A is barium, so I put 1 mole barium. And under that, you're going to put the mass of A found in the periodic table. So when you find barium on the periodic table, look under BA, and you'll see that the mass is 137.33 grams. Next, we're going to put how many moles of B are in the balanced equation. B is what we're trying to find, and we're trying to find silver. Silver is Ag, and when you look at our balanced equation, you'll see that there are 2 moles of Ag. So that's what your chart should now look like. So under 2 moles Ag, we're going to put how many moles of A are in the balanced equation. A is what you are given, which is barium, and as you can see in the balanced equation, there are no numbers in front of barium, which means you simply write 1 mole Ba. So in the last row of our chart, you're going to put the mass of B in the periodic table. B is what you're trying to find, and we're trying to find silver. So when you look in your periodic table, look under Ag, and you'll find that the mass of silver is 107.87 grams. And finally, on the bottom right of our chart, we're just going to simply put 1 mole B. We already know that B is Ag, so once you have your chart written out, it should look like this, and now we're going to multiply across the top and across the bottom. So when you multiply across the top, you get 4,530.54, and multiply across the bottom, you get 137.33. So now we're going to divide them, and you end up with 32.99. With an answer like that, you can just round it up to 33, so our final answer is 33 grams of silver. Thank you for watching, and I hope you now understand how to do stoichiometry.